Hi, I'm Akila Siriweera. This is my presentation about Survey for Cloud Robotic Architecture for Multi-Cloud Heterogeneous Robotic, and Stochasticity-Aware Cloud Robotic Workflow Scheduling. This is the outline of my presentation. First, I talk about architectural design process for the heterogeneous cloud robotic, and then I will move to the cloud robotic workflow scheduling. As of the motivation of the architectural design process for the heterogeneous cloud robotic, then the cloud robotics become essential part in the robotics engineering. Fukushima robotic test field facilitates for diverse range of robotics requirement, such as it is involving aerospace, consumer, disaster response to the underwater. These heterogeneous robots need generic platform for data lake and diverse requirement of processing included analytics. A platform requirement for heterogeneous robotic becomes a system of system requirement. Then the unified architectural framework is the preferred technique to modeling the SOS solution. The reference architecture is a leading technique to instantiating modeling SOS involving unified architectural framework. As of our requirement, first we conducted a comprehensive survey on cloud robotic architecture. Then we learned that a model-driven next-generation cloud robotic platform is the requirement. Then based on that, we proposed comprehensive modeling for the MNCRP, and also we defined the reference architecture for the MNCRP. Our solution is the first of this kind product so far in the cloud robotic domain. This is our survey matrix. We identified architectural design process, provision for industrial evolution, and also provision for secured heterogeneity are three main metrics of our domain. Then we categorize each dimension into 4 parts and give marks as this table shown. After the survey, this is the one of the graph of the survey. You can identify none of the solution does not focus on UAF grid, and also none of the solution does not provide adequate provisions for the industrial evolution, except our solution. Almost half of the product does not provide adequate modeling for the reference architecture, either system architecture, and also it only one of the half product provide either modeling for the reference architecture or system architecture up to some sort of level. Then based on that things we learned from the survey, we define the flow for the architectural design process as it's shown in this slide. First we define the abstract flow of design and derive the solution. After that we design the abstract decision flow for framework for the MNCRP. You can see context, goal, and modeling are our flow. Under this flow, we need to define abstract modeling and principle for automation. Based on that, we prepare the reference architecture. After that, system architecture. Then based on that, after that, we define the subdimension on of the main dimension as it's shown in the previous figure. You can see the subdimensions and main dimension. After that, we disambiguation the adequate reference architectures as follows. Then based on that modeling process we followed, finally we derived finalized model for the reference architecture as M1, M2 and M3. You can see M3 mainly contain physical layer, infrastructure layer and analytical layer. The physical layer mainly dominant the user cases. The infrastructure layer dominant by the cloud robotic ecosystem. The ecosystem comprises 7 key components. We can name them as the systems. We can name them another name modules. Then based on those modules, cloud robotic ecosystem has been made. After that, we define the system architecture for the MNCRP, which involves 4 user cases as it's shown here. You can see team 1 team 1 is the drone outsourcing company, team 2 is the autonomous vehicle company, team 3 is the factory automation company, and also team 4 is the military service provider. Based on that, we derive the system architecture. You can see edge layer, fog layer, and the center cloud layer. This is the multi-cloud we define here. Decentralized multi-cloud. In decentralized multi-cloud, it comprises cloud 7th module cloud robotic ecosystem. As of the future work of this, beyond the already done works, we are working for the UAF grid for the MNCRP. After that, I'd like to move to the cloud robotic workflow scheduling. First, we conducted a survey for the cloud robotic data in wired and wireless mode. You can see we employed 3 communication protocols: MQP, COBA, and MQTT. This initial results was derived by one of our peer researcher, Yoshino-san. I used his data to conduct this survey. As you can see, according to the context, the data involving wired or wireless mode, the communication patterns show heavily stochastic patterns. Then we learned that the stochastic awareness heavily depends on communication protocol, data bandwidth, and the task. Therefore, we are working to propose a QoS aware stochastic scheduling technique for the cloud robotic workflow scheduling. As you can see, it mainly contain geo-distributed cloud robotic workflow scheduling architecture. Thank you.